In the previous lesson, we examined how a simple operation like adding two binary numbers can be implemented in a typical CPU. During that discussion, we also realized that this operation of adding two numbers is not a single task but a process that involves multiple steps. But that was only about generating the required signals for the RTL logic circuits to carry out this addition part of the instruction. In there, we assume that the CPU knows that what it has to do is an addition operation. When the instruction is in the memory of the computer, CPU doesn't know what that instruction is. CPU can't even see that what that instruction is. It only knows that it has to bring that instruction from that particular address, or there's an instruction at that particular address. What is there in memory can be an add instruction or something else even. So even to see what that instruction is, the CPU must first bring the instruction itself from the memory into the CPU and then see what actions it need to be done. So executing a CPU instruction is also a complex task. It is not a single task but a process that involves a series of steps that has to be very carefully sequenced and synchronized, and that has to be done for every single instruction that the CPU executes. So let's look at what are those steps and how they are organized inside the CPU. The very first thing that the CPU need to do before executing an instruction is to bring the instruction itself from memory into the CPU. For this purpose, CPU has a special register or a special memory location inside the CPU which tells the CPU from where the instruction has to be brought in. Basically, it contains the address of the next instruction that the CPU has to bring in. So the CPU will look at this register, figure out from where the next instruction to be brought in, and then execute the necessary steps to bring that instruction from memory into the CPU. Basically, the CPU has to execute a memory read cycle to access that memory location and bring that into the CPU. So that is the first step. We call that the instruction fetch step. The second part is the CPU need to now understand this instruction. You know that an instruction has two components. There's an opcode or the operation code which tells the CPU what action to be done, and then there's operands which tells where the data can be found. So the CPU has to decode this instruction and understand what is that opcode, which ALU circuit that it need to activate, and from where it need to get the data into the ALU. So that is called the decode part of the instruction. The next step is that when the instruction requires operands or the data to be worked on, those data or the operands has to be made available for the instruction. In some cases, the data may be already available within the CPU, for example, in some of the CPU registers. But in other cases, the data has to be brought into the CPU from memory. So if at least one of the operand refers to a memory address, then CPU has to again run another memory read cycle to bring that data from the specified memory location or memory address back into the CPU. So when all the data are within the CPU is ready to go to the next step. So that the step that where we bring data from memory or other locations, sometimes it can be IO devices, into the memory CPU is called the operand fetch part of the CPU instruction execution. Then when everything is ready inside the CPU can start the actual execution of the instruction, like what the execution of the add instruction, add operation that we looked in the previous lesson. For that, again, the CPU has to generate number of signals in a particular sequence to activate different parts of the CPU so that the operation can be carried out in the expected way. Different operations will require different parts to be activated in a particular sequence. So this part of the instruction is called the execute component of the instruction. So likewise, the instruction has 4 different components. Execution of the instruction has 4 different components. Now these 4 components has to be repeated for each and every instruction that the CPU is going to execute. First, it has to fetch the instruction, then decode the instruction, then fetch any operands that are required, and then finally execute the instruction. So these 4 steps, which is repeated for every instruction, is called the instruction cycle. It's called a cycle because it repeats for every instruction. And it has, out of the 4 components that the instruction cycle has, the first 2 components, which is the instruction fetch and the decode, is more or less similar for all the instructions that are in the CPU. Because before executing any instruction, the CPU must first bring that instruction to the CPU. So that involves a memory read cycle plus a process where CPU determines from where the instruction has to be brought in. So it keeps some internal references on where the instruction has to be brought in, and from there it brings the instruction and then update that reference so that when this cycle is over, when it starts the next cycle, it knows where the next instruction to be brought in. We will see how this happens in a while with a different discussion. So the latter 2 part of the instruction, the operand fetch and the execute part of the instruction, can be variable. It can differ from one instruction to another. For example, if you take instruction like the no operation instruction, that will not require any operand fetch or any execution even, because that is not doing any task. On the other hand, some instruction, for example, reading from a memory location and storing that value in the in an internal register of the CPU, or adding that value with something inside the CPU through an ALU, might need multiple operand fetches. It might even need to access the memory multiple times to get that data. So that involves multiple memory read cycles, or and sometimes even to store the memory results in the back in the memory write cycle, so that the process, the time taken to execute that part can be very much variable and depending on one instruction to another. The execution part is also like that. Some instructions, the execution will only have 1 or 2 steps, whereas other instructions, it might have more than that. It might take a bit longer. So in a typical instruction, the fetch and the decodes part are fixed, or the time or the steps required for that is fixed, whereas the operand fetch and execution part can vary from one instruction to another. So there, the time taken by those instructions is again another factor that determines how fast the CPU can work. In some CPU designs, the time taken for these operations is very small, so that the CPU can do tasks much faster. In some other CPUs, the number of steps that each of these part will take will be very large, so that the CPU will need much longer time to execute an instruction.